Hello. Today I'm going to try and teach you how you can hook up this HC-SR04 Ultrasonic Ranging Sensor, so like a sonar sensor that just gives you the distance in front of it to the nearest object, and how you can interface that with the Arduino. Now, if you're looking at it, it looks kind of like it has eyes. One of these guys sends out like a sound pulse. It'll go hit the object in front of it, and then this guy will hear the echo. And based on the amount of time since it sent out the sound pulse and when it received the echo, you can figure out how far the object is in front of it. Now it's got 4 pins on it, this VCC thing, which you just powers it. That's a way of saying plus 5 volts. So just hook this up to your Arduino's plus 5 volt rail. It's got the trigger, which you're going to send a little tiny pulse to trigger it to send out the sound. It's got the echo pin, which is going to go to plus 5 volts after the sound pulse is sent out and while it's waiting for the echo. And you should hook up the ground pin of your ultrasound thing to the ground for your Arduino. So here's that written out. So yeah, it's got 4 pins, VCC, which you hook up to 5 volts, ground, which you hook up to ground, just to give it power. For the trigger, you should set it up to some Arduino digital pin, and echo, which you should also hook up to some Arduino digital pin. Doesn't really matter which pin, except in general, don't fully recommend you use 0, 1, or 13. Those have added complications. 0 and 1 are used for serial communication, so they can cause unforeseen consequences if you're also using them for other things. And pin 13 is hooked up to a little LED, so it's got lower power than the other pins because it's also powering that LED. Anyway, so we got these 4 pins, the 2 power pins, the trigger, and the echo. Point of the trigger pin is you send a 10 microsecond, 10 millionth of a second pulse to it, just using digital write and a new form of delay that delays for shorter periods of time, to just start it out at low, 0 volts, to whatever pin's hooked up to the trigger thing. Set it to high for 10 microseconds, 10 millionths of a second, and then set it to low again, and that's the signal to our little eyes to send out that pulse. And then once you've done that, our echo pin, it's normally low, it's normally 0 volts, but it'll go to high until it receives the echo, until it hears the echo of that sound pulse it sent out. And that's it. That's how the whole thing works. Now we're going to need some new commands to make this work. We can't delay milliseconds if we need to send out a pulse that's microseconds. So instead of delay, which normally delays for milliseconds, we're going to use delay microseconds, which will wait for a certain number of microseconds. Specifically 10 would be a good one. So we can have a high pulse for 10 microseconds. We're also going to need to know the pulse in command. Pulse in gives you the amount of time in microseconds that this pin, which will be whatever pin you've got on your Arduino connected to the echo pin. So if the echo pin here is hooked up to pin 12, this echo pin thing would be 12. Now it's by default low, but it goes high when it's waiting for the echo. So if we're timing how long it's high for, we would do pulse in 12 if 12 on the Arduino is connected to the echo pin on the HC-SR04 ultrasound thing, and then we'll do high there. And so that's equal to the microseconds that pulse is going for. Microseconds since the pulse left till when it hears the echo. And that could be quite a big number, so it doesn't return that as a int. It returns it at what's called an unsigned long. So this is our first variable type that is 2 words. Unsigned just means it can never be negative, because, you know, time for the echo to come back it's never going to go back in time. So it just uses that one bit that's usually used for plus or minus, just to let it hold a bigger number. And long is just a type of integer that is twice the size in memory of an int. So this can hold a very big number. Instead of a couple billion, it can hold, who knows, like octillions, something like that. So that's the time in microseconds. So this would be a good line. Unsigned long, just like you'd be like int x equals 5. In this case, you're like unsigned long time, which is just a good name for your variable that's going to hold the amount of time it took the sound wave to go out and come back. Equals pulse in 12 if you've hooked up that echo pin to pin 12, whatever it happens to be otherwise, comma high, because it goes to plus 5 volts while it's waiting for the echo. All right, so first order of business, we want to send out that pulse. And so how I'd recommend you do that, I don't want to just write out the code for you, but you can probably figure it out. So using digital write and delay microseconds, first you want to write the pin low using digital write and wait for 3 microseconds. That'll do this part, just to make sure it was low beforehand. And then you want to write the pin high, so digital write it high, and wait for 10 microseconds using delay microseconds. And then you got to write the pin low again. And that should, if you send that to the pin that is connected to the trigger pin of your sonar sensor, it'll send out that sound pulse. That's step 1. Step 2, we want to figure out the amount of time it took for the echo to go. So as soon as you send out do that little 10 microsecond pulse to the trigger pin, it sends out a very specific sound burst, technically 8 little sound pulses, and then it listens for them. The echo pulse goes high and until it hears the echo, and then it goes to low again, and pulse in will give us the amount of time in microseconds that we were waiting for the echo of this guy. That's about it. So don't forget that line. Now, once we got the time it's out there, we're not really interested in time for the echo or for the sound to go out and come back. We're interested in the distance from our robot to the nearest object. Now, logic for that is we need a bit of this physics. Distance is equal to velocity times time. So, for example, if you're going 10 meters every second, for 2 seconds, you're going to go 10 meters. 5 meters in the first second, 5 meters in the second second. So how far you go is just how fast you're moving every second times your number of seconds. Velocity times time. Now, speed of sound in air at normal temperatures and pressures is 343 meters per second, where if you do some delightful unit conversion, you will find out that's equivalent to 0.0343 centimeters per microsecond. So not super far in a microsecond, but there's an awful lot of microseconds in a second. If we multiply that by our time, we do our distances, velocity by time, in microseconds, we should have our distance to the object in front in centimeters, except we're not timing the time it takes the sound to go and hit the object. We're timing the time it takes to go and hit the object and come back. So we want to divide that distance by 2 to get the distance from the robot to the object in front of it, rather than the distance from the robot to the object and back. So all we got to do, take that time, which we got previously using a line awfully like this, and then take that time, multiply it by 0.0343, and then just take our answer for that and divide it by 2. And that'll get us the distance from our robot to the object. I recommend you save it as your distance as a double, though you could do other things. If you want it to be an int or whatever, you can do that. You just have to use casting, if you remember. Just the thing with the variable you want to convert it to in brackets. And that's, and one last step. Once you've got that, you've got a way of coming up with a distance using this. but it's good to package it into a function. So first of all, you want to make a function header. So this will be our first function that calculates something that's equal to a number and doesn't just do something. So instead of it being void sonar, it's going to be double sonar, because the whole thing is going to be equal to a double type variable. And then just basically copy and paste all that code you had before, like to create the pulse, the 10 microsecond pulse to the trigger, and to find the time using pulse in, and then the little bit to figure out the distance with your math with the speed of sound. And then just add that last line inside your sonar method, return distance. And now anywhere you want in your code, you can just type in sonar bracket bracket, and that's just going to be equal to the distance from your robot to the object in front of it. So you can have lines like this. You can just say, hey, float distance equals that, or you don't even need to put in a variable. You can just, or sorry, this should be double distance equals sonar bracket bracket. You could also just put it straight into an if statement and say, hey, if the value from using the sonar sensor, if the distance from the robot to the object in front of it is less than 15 centimeters, probably want to turn so we don't hit that thing. So turn right at 180 power for 800 milliseconds. Make this little method and use it with your robot and try to get it running around the place avoiding obstacles. Hopefully that helps. Thanks for listening.